Okay, so let's talk about a horizontal launch now. And this could be something like, hey, I'm shooting a gun and angling it out horizontally. And the path, it still follows a parabola. It will hit like that, but it really only looks like a half a parabola. It could also be something like a car driving off a cliff. And when it crashes, it hits at a certain distance. But the important thing to keep in mind for horizontal launch is that there are a couple additional variables you know. Because it's horizontal, meaning the angle is 0 when it is launched, the initial velocity is all in the horizontal direction. So some things you can fill in right away. So let's see, vertically, 0. Your initial velocity is 0. Horizontally, your initial velocity is whatever v is. So maybe you drive off at 10 meters per second. So in that case, your initial velocity horizontally is 10 meters per second. And your initial velocity vertically is 0 meters per second. Now you need at least one more piece of information to solve this, but let's say, for example, you know the height is equal to 20 meters. So you're driving off a cliff that's 20 meters high, or you're shooting a gun from a height of 20 meters, and you know that its initial velocity vertically is 0 and horizontally it's 10. So when it hits, it's gone a total distance of 20 meters, but it's done it in the negative direction, so negative 20 meters would be your vertical displacement. Your initial velocity is 0, your acceleration is negative 9.8. You have 3 variables, you can find final velocity and time. And it's pretty easy and straightforward to do so. You just always need to make sure you're working with the right side. So let's say d equals VIT plus 1/2 AT squared. So the distance is negative 20 equals 0, because your initial velocity is 0, plus 1/2 negative 9.8 t squared. And in case you haven't figured out, I am working vertically, because vertically the distance is negative 20, vertically the initial velocity is 0, vertically the acceleration is negative 9.8. That gives me a time of, let's see, it ends up being negative 20 equals 1/2 AT squared. I can get rid of that term, so time is really just the square root of 20 times 2 divided by 9.8. Which is the square root of 4.08, so it should be about 2 seconds. And this is the same exact time it takes for something to fall 20 meters, 2 seconds, right? So when it hits at the point 2 seconds. How far does it go in that time? Well, remember, horizontal is constant speed, so distance is velocity times time if you're moving at a constant speed. So it's just 10 meters per second times 2 seconds equals the total distance traveled of 20 meters. So it's gone 2 seconds, it's traveled 20 meters. That's one of our answers. Its final velocity is the same as its initial velocity. Here, if you want to know the final velocity, remember it's accelerating at negative 9.8 every second. So after 1 second, it's going at negative 9.8. At 2 seconds, it's going negative 19.6. You can get that by acceleration is change in velocity by time. So the change in velocity is acceleration times time, 9.8 times 2 seconds. And again, you just need to be sure you know what they're giving you. Sometimes questions get more complicated than this, but just pick a spot. Like if you need to find out, hey, it's traveled negative 2 meters, how fast is it going? Just put your negative 2 meters in, work with what you know, and figure out the rest. And we'll do some problems in class too. Thank you very much for watching.